in biological research and technical services through our mission, the 5 Ps. To promote advancement in biological research and services, to produce world-class research in different areas of biology, to perform biological analysis and technical assistance, to provide trainings and webinars, as well as to protect life and environment through the laboratory's activities. The BRSL has several labs: the cell culture, microbiology, and DNA labs, as well as a general equipment lab and a microscope room. We are also in the process of constructing a laboratory animal facility. The lab's research thrust is diverse and includes bioarchaeology, biorisk assessment, food safety, toxicity studies, natural products, phycology, sustainable or renewable energy, and virology. When things go back to relative normalcy, we hope to offer you again our hands-on workshops in basic and advanced molecular biology techniques, lab animal care and use, microalgae, and plant chromosome preparation. Because of the pandemic, laboratory services are currently suspended, but normally we also offer bioassays such as cytotoxicity and genotoxicity testing, and microbiology and molecular biology analysis, as well as microscopy, research assistance, including lab and equipment use, consultations, and of course, webinars and lectures such as the one we are having today. So to welcome you to the 5th installment of the BRSL webinar series with the theme, The Power of Detection from Microbes to Chemical Compounds, I present to you the new director of the Natural Sciences Research Institute, Dr. Elmer Estacio. Sir?
Just a moment. Hello, good morning, everyone. Is the connection okay?
Yes, sir.
All right. Yeah. Sorry about that. Good morning, everyone. I'm Elmer Estacio. As the newly appointed director of NSRI, I am truly delighted to have been invited by Dr. Pai Vital and BRSL to deliver the welcome remarks for today's BRSL webinar series, episode 5, I think, right? Yeah, I am truly delighted. Hindi po yan lip service because in the institute where I come from the National Institute of Physics, we don't have this regular engagement wherein recent laboratory member graduates are invited to give talks on their research highlights to a general audience such as this one and such as this webinar. Especially in the time of COVID, these meetings are of utmost importance, not only in disseminating scientific research output, but more importantly, these webinars promote collaboration and exchange between scientists and students, such as what we have in the audience this morning. Perhaps looking back, we should also think about emulating this practice of BRSL in our institute. So, yeah, for this morning, I welcome today's speakers, Rian Sarza and Josette Abelio Caduldulan, as well as everyone in attendance. Coming from someone whose field is neither chemistry nor biology, I would like to say let us all learn from these two speakers. So maraming salamat po. Thank you very much.
Thank you very much, Dr. Estacio, for that warm welcome. I will now turn you over to Erna to introduce our speakers. Erna?
Thank you, Jessica. Our first speaker, Mr. Rian Sarza, is an MS Chemistry and BS Food Technology graduate from UP Diliman, UP NSRI. One of his research interests is in the development of rapid testing methods for food analysis. In his free time, he likes to travel, watch Korean dramas and shows, and listen to K-pop. For his research, which is on the development of a paper-based device for quantifying a class of antioxidants in tea-based beverages. Let us all welcome Mr. Rian Martin Sarza.
Okay na po ba? Kikita na po ba? Hello?
Okay na po.
So, good morning everyone. So, let me introduce myself again. So, I am Rian Martin Sarza. So for today, I will be presenting to you part of my literature review sa aking thesis, which is paper as a detection tool. Okay. So there are many reasons why we would do chemical testing or analysis. So for example, we want to know the composition of a certain soil sample taken from a farm. There's also ensuring that the food or cosmetic products that a company produces is within the set limits. So let's say kailangan yung sugar content mo is up to this level lang. So you have to do chemical testing for that. So we also do chemical testing when we want to know if a certain sample we have is an authentic one. So example nito is yung previously naging issue with your honey and your suka, yung ating vinegar, na sabi nila is na napepeke na. So paano natin malalaman if authentic ba siya na suka or honey? We do chemical analysis. We can also do chemical testing to determine blood glucose content or the presence of alcohols and drugs dun sa ating blood samples, especially when we do forensic analysis. So normally, these testing involve the use of chemical instrumentation, and some examples of which are the following listed. So we have your gas chromatography, your liquid chromatography, and your spectrophotometry. So these instruments are known to give accurate and precise results and could sometimes detect analyte quantities at very, very low levels. But that is
Excuse me, Rian.
Yes.
Rian, may gray sa gilid. Tsaka sa taas.
Wait lang po.
May exit to full screen ka.
Okay na po ba?
May mga gray areas pa rin. Ayan, may maliit sa corner. Ayan. Okay.
Tinago ko na.
Okay. Better.
Lumalabas po talaga siya pag may
nag-exit to full screen ka.
May nagpa-pop up po talaga pag may pumapasok. Okay. So going back.
Sige. Okay, sige.
So going back, so as with any method, there are still disadvantages or issues that come with these chemical instrumentation. So one example is the price. So if you are familiar with how to procure these items, most of these chemical instrumentations will cost around millions na. So napakamahal niya. So hindi siya accessible to anyone. Next is usability. You have to be a trained analyst for you to use these chemical instruments. So hindi siya basta-basta nagagamit. Next is portability and need of electricity. So hindi mo siya pwedeng dalhin sa field. If may kailangan kang analysis na gawin, let's say in riverbed, hindi mo siya pwedeng gawin dun mismo sa site. So chemical instrumentation exists, but it is not perfect. So how can we address these issues? So one way na address nila to is through your microfluidic chips. So what are microfluidic chips? These are devices which use circuitry and electronics to control fluid flow in a micro scale. So an example of which is yung picture natin sa right side, which is your lab on chip. So you put your sample, yung nakikita niyo yung red. So yan yung ating sample. Then ilalagay siya dun sa ating chip using that sample entry area. And within that chip, ma-analyze niya na whatever it is yung kailangan mo for that sample. In these microfluidic chips, multiple steps can be combined in a single one. So hindi ka na yung mag-pre-treatment pa, or let's say multiple chemical reactions kailangan mong gawin, pwede mo na siya pagsamasamahin in one chip. these microfluidic chips have simplified and miniaturized chemical instrumentation while keeping its power of doing high accuracy and high precision analysis. However, there are still some issues with these microfluidic chips. So what can we do to further develop these microfluidic chips to lessen the issues that we have with them? So dito ngayon papasok yung what we call your paper-based devices. So our paper-based analytical devices, or what we call PADS, started first as your litmus paper. So yung ginagamit natin for determining the pH of a certain solution. It was developed around the 1800s, and it enabled the field measurements of pH. 1970s saw the appearance of lateral flow assays, so as pictured below. So in a lateral flow assay, you put your sample in the sample pad, then through capillary action, mag-flow naturally yung inyong sample doon sa inyong lateral, sa ating LFA, then magkakaroon na ng detection whether present yung inyong analyte or hindi. So it's more of a yes or no device. So improvements from modern pads are derived from concepts used in microfluidics. So instead of freely flowing through the test strip like in your LFA, you control the direct flow of liquid in your modern pads. The use of paper in pads made it cheaper. So cheaper than the microfluidic chip, portable, easy to use, and robust. So different properties of paper have made it suitable as a substrate. So one example is yung ating capillary action or the free movement of fluids in your paper. Next is flexibility, kasi mostly yung ating microfluidic chips, gawa siya sa ating polymers or plastic. But unlike your plastics, yung ating paper is very flexible, so pwede kang gumawa ng any pad in any shape. Next is absorbency and thickness. You also have porosity. So high surface to volume ratio. So for yung high surface to volume ratio, mas marami yung pwedeng reaction sites than your normal microfluidic chip. Also, kasama dito yung natural origins, so hindi magiging problem yung biocompatibility ng inyong pad doon sa sample. So modern pads use patterning techniques to create these flow channels. So the flow channels allow for the directed flow of liquids unlike in your LFAs. Multiple steps and multiple target sample detection can be done because of these flow channels. So numerous fabrication techniques have been developed and different sensors have also been used for your modern pads. The application of these pads have also expanded to various fields. So punta mo tayo sa fabrication. So different fabrication of patterning techniques have been developed to create flow channels in your paper. These channels are your hydrophilic zones where fluids will flow bounded by a hydrophobic border. So what do I mean by this? So let's say you have this test strip. So meron kang dalawang detection zone, yung ating zone A and zone B. And you have your sample zone where you put your sample. So wala siyang border. So your reagents can move freely within your paper. Pag naglagay ka ng sample sa inyong sample zone, since wala siyang border, wala siyang harang, it can freely flow wherever doon sa inyong paper. So kakalat siya. Pagdating dun sa detection zone, yes, magkakaroon ka ng reaction na hinahanap mo, but there is a possibility na maghahalo yung products mo from those different detection zones. Kasi nga wala siyang harang. So nagkakaroon ka ng intermixing of reagents which is problematic for your analysis. So in creating these flow channels, so meron kang hydrophobic border, the one in black. So now you can control where and how your fluid will flow. So again, naglagay ka ng sample sa inyong sample zone. Yung inyong sample will now move along within the borders lang. And pagdating yung sample sa inyong detection zone, you have two different products. So hindi na siya nagkakaroon ng intermixing, mas madali mong nakikita yung inyong product. Most especially if what you're doing is quantitative based on the color of your detection zone. So there are different fabrication techniques that have been developed. So these are some examples. So you have your printing, drawing, dip coating, photolithography. So in printing, what we use is a printer ink system to apply these hydrophobic areas. So marami tayong klase ng printer na ginagamit for the fabrication. So these include wax printing, inkjet printing, laser printing, and screen printing. So I think we're familiar naman with inkjet and laser printing. The difference lang with these two methods is you modify the ink that you are using. So for your inkjet printing, instead of using your normal water-based na ink, hahaluan mo siya ng inyong wax and a solvent for that wax. For your laser printing naman, since yung ating laser printer uses a solid toner, what you add is a hydrophobic solid din. So an example of this is a hydrophobic nanosilica. For your wax printing, I'm not sure if everyone is familiar, pero we have printers that uses wax as toner. So wala ka ng modification na gagawin pa for these printers. Kasi automatically, since wax siya, hydrophobic na yung ink na ginagamit mo. Then screen printing, this is what we usually do pag nagpiprint ng mga t-shirt. So yung ganun. So the advantages and disadvantages vary per printing method na gagamitin mo. The most common disadvantage for these printing methods is the amount of modification that you have to do para dun sa inyong printer. Kasi you have to ensure that your printer can use those reagents na hinalo nyo dun sa inyong ink. So for drawing, so you manually draw these borders using a modified ball pen. This is an extremely cheap method, but the resolution can be very low. So an example provided by one paper is the one seen sa ating right side. So this is a freehand drawing of an ink that contains silver particles and wax. So since silver yung ginamit niya, aside from being hydrophobic because of the wax, the silver makes the drawing conductive. So kaya nakita nyo may umiilaw yung LED light doon sa picture. So next, dip coating. This is where you dip the paper onto wax, pero you need a metal mold for this one. So looking at the picture, so yung light gray and yung white is our paper. Then iipitin mo siya ng iron mold na may shape. I-dip mo yung buong paper dun sa inyong wax, then since may nakaipit na mold dun sa ibabaw ng paper, that area will not be coated by your wax. So lastly, photolithography. This is where you soak your paper in a photoresist solution and then you bake it in an oven. After that, i-expose mo siya to UV light para ma-form yung inyong pattern. So the one exposed to UV light, siya yung magiging hydrophilic area nyo. Tapos yung natabunan will be your hydrophobic area. These require multiple steps and possible contamination of the hydrophilic zone with the photoresist reagent may happen. So sensors for your pads. So meron kang pad na fabricate mo na siya. How do you analyze the data na na-produce niya? So there are two common methods that are being used. So we have optical and electrochemical. So for your optical, this is the simplest and most inexpensive method of analyzing your data. and can be affected by different variables depending on the sensor that you are using. So the three most commonly used is colorimetric, fluorescent, and image analysis. For your colorimetric optical sensor, you use a chromophoric reagent. When I say chromophoric, this is a reagent that produces a colored product when it reacts with an analyte. So we have different chromophoric reagents for different target analytes. But one problem with these chromophoric reagents is specificity and selectivity. One example is yung sa ating Follinshokalto method, the one we use to quantify polyphenols. It is very sensitive to antioxidants, pero common reducing agents may also react with your Follinshokalto reagent, which is problematic, especially when you translate the method into a PAD. So an example is this one. So you can see from the picture, nagbabago yung kulay ng inyong test area as the concentration of bacterial cells increases. So for yung ating ST femurium, from a yellow sample zone, nagkakaroon ka ng deep red color formation as the number of cells increases. For your E.coli naman, hindi siya ganun ka-visible, pero from the yellow starting reagent, mas nagiging orange siya. So for your fluorescent sensor, so what you have is you elicit a fluorescent reaction between the analyte and the detection reagent. But for this one, you often need additional instrumentation to actually detect the fluorescent that has happened. Lastly, you have your image analysis, wherein you take a photograph of your pad and then translate it into numeric data. So for those who are familiar with photo editing, we know that in our computers or in our photo editing programs, you can actually quantify colors using the RGB color system. So RGB stands for red, green, and blue. So using that color system, you can quantify the picture, and using those numbers, pwede mo ngayon gawing quantitative yung inyong measurement, yung inyong analysis. So for the second type of sensor na commonly ginagamit, you have your electrochemical. In your electrochemical sensors, you actually embed your electrodes as part of the pad system. So as shown dito sa picture. So you have your electrodes here, yung black and gray parts, black and gray rectangles, and yung white part is yung ating paper. So ini-embed mo siya doon na sa loob ng inyong pads. So unlike your optical methods na madaming possible source of contamination, your electrochemical sensors are insensitive to light, dust, and insoluble compounds. So let's say, for example, yung sa optical sensors nyo, when you're looking at your color, pag hindi evenly nag-develop yung color nyo around your detection zone, magiging problematic siya when it comes to quantification of the data you have obtained. Kasi kunwari, circle siya, yung pinakaloob ng circle nyo sobrang dark ng color, pero yung outer parts niya sobrang light. So, uneven yung naging analysis ng pad nyo. Pero for yung electrochemical, hindi na siya magiging problem pa. So, there are different electrochemical methods na pwedeng gamitin. So, we have your voltammetric, potentiometric, and conductivity-based. So, yung ating pads, marami na siya naging applications in different fields for the past several years na ongoing in development niya. So for medical diagnostics, your pads have been developed to detect multiple biomarkers. So these biomarkers include nitrite in your saliva, viral DNA and RNA, antibodies, pathogens, blood glucose. So some examples ng ito. One major pitfall ng PADS used in medical diagnostics is poor detection limits. So most of the time, especially when we do blood analysis, we're looking at very, very minute concentrations. And yung maliliit na concentrations na yun, most of the time, hindi na siya na-detect ng ating mga PADS. Kaya siya one big problem for medical diagnostics. Next is complexity of your sample matrix. So balik tayo sa ating example, yung ating blood, marami siyang contents. So if you're looking at, let's say, blood glucose content lang, maraming possible interference dun sa inyong analysis. So another pitfall is reagents used can degrade easily, especially if enzyme-based yung inyong ginawang pad. Very sensitive yung ating enzymes. So kailangan maingat yung pag-handle natin doon sa pads. And multiplex pads are uncommon. When I say multiplex, ibig sabihin nun, marami kang ina-analyze na analytes in one paper device. So this is one example. So a pad that detects blood glucose levels. So ito yung ginawa nilang layout. Then what the pad does is enzymatic yung reaction niya. So the glucose will react with different enzymes para mag-produce yung ating end colored compound. And based on the color of that detection zone, malalaman niyo yung concentration ng glucose dun sa ating blood sample. So as we can see dito sa visual detection, mas nagdi-deepen yung blue-green color niya as the blood glucose concentration increases. So an actual analysis was done. So and ito yung pinapakita dito sa ating peers analysis sa baba. So ito yung sinasabi ko kanina, problematic yung colorimetric since possible na hindi even yung pag-develop ng color dun sa ating pads. So lalo na pag quantitative yung measurement nyo, hindi nyo siya maka-quantify ng maayos. So for environmental testing, portability and simplicity is the biggest advantage. So you can bring your pads to your actual test site. Areas of improvement, so almost same lang siya with your medical diagnostic pads. So specificity, so kailangan yung target analyte lang yung magre-react sa kanya, selectivity, stability, and on-site data analysis. So for environmental testing, marami nang na-develop to detect your pH, inorganic ions, so mga heavy metals, pesticides, and gaseous compounds. So possible na rin ma-detect ng pad ang gaseous compounds. So one example is this one, shown in the picture. So for this pad, it detects two analyte. It does two analysis. So meron kang for pH, yung medyo red, and iron content ng water yung medyo bluish. So one thing that is unique with this type of pad is they use smartphone for your data analysis. So kina-quantify nila yung data na produce ng pad using a smartphone camera. So next, food quality. So assessment of various analytes related to food quality and food safety. So pwedeng your amine vapors for the degradation of your fish produce, vitamins, minerals, mycotoxins, pwedeng living species like your bacteria. One problem with pads for food quality assurance is yung specificity. So marami kang possible analytes in a food sample and pwedeng siyang mag-interfere with your analysis. So, pinakita ko kanina yung sa ating E.coli and sa salmonella. Yung pad na de-develop na yon is actually for food analysis, so for food quality assurance. And aside from that test pot, gumawa rin sila ng parang thermometer or what they call a chemometer. So based on the distance of the red color malalaman nila kung gaano karami yung actual cells doon sa inyong sample. So the farther the red color is doon sa inyong thermometer, mas mataas yung number of cells present in your food sample. So for what I did for my master's thesis is related to food quality assurance. So I developed a cheap, simple, easy to use device that can detect and quantify total polyphenols in tea-based beverages. So for those who aren't familiar with what polyphenols are, these are your antioxidants na mahanap sa pagkain. So the pad was developed and intended for the use of our small to medium scale enterprises that do not have the means to acquire and utilize chemical instrumentation due to its price, so mahal, and usability, the need for a trained analyst. So unfortunately, hindi ako pwedeng magpakita ng pictures ng aking dinevelop na pad due to intellectual property concerns. Pero what I can say about the pad that I have developed is that there is a 1 to 11% difference in obtained values between the pad and UV spectrophotometry method. So this spectrum method is the industrially accepted method for quantification of total polyphenols. That 1 to 11% is not significantly different from each other. So based on ano ba yun? So masasabi mo na comparable yung values na na-obtain ng inyong pad from the instrumental method. So unlike the instrumental method, the pad is not affected by interfering compounds. So the most common interfering compounds sa ating food samples, especially beverages, is sugars and ascorbic acid or vitamin C. So for the pad that I have developed, na tanggal ko yung interference na yun. The pad is also stable and usable up to 57 days in refrigerated storage. So pads have already existed for a very long time, but there is still growing interest in the field due to the advantages it gives. So what are the projected research direction for our pads? So first one is the focus on multiplexing. So again, multiplexing is you want to do multiple analysis in one single pad. So hindi ka na magkakaroon, let's say, ng one pad for sugar, 1 pound for vitamin C, 1 pound for this certain mineral. Pwede mo nang i-analyze yung sample in just one pad. Next is improvement of sensitivity, reproducibility in real-world environments. So iba kasi yung environment sa loob ng lab where we develop these pads and pag ginamit mo na siya in the field. So there are still many ways that we can improve this, including din yung sensitivity. Next is lengthening of the shelf life and enhancement of stability. Kasi one common theme with the pads that have been developed is that yung buhay niya is madalas weeks lang, 2 to 3 weeks or up to 2 to 3 months. So we can find a way how to lengthen that shelf life para mas maging usable siya, and pag kinommercialize mo siya, mas magiging mura siya. Next is development of a proper and adequate packaging. Since like what I've said before, there are reagents na very sensitive to the environment. So very sensitive to heat, very sensitive to light. So we have to develop proper packaging for these pads para hindi maapektuhan yung ating reagent na naka-embed dun sa pad. Next is development of data interpretation methods. So the trend right now is going from the qualitative to the quantitative. So how can we improve data gathering in the quantitative side ng ating pads? So lastly, transition from lab to commercial applications. Kasi one problem with the developed pads right now is that nasa-stock lang siya sa lab. Hindi siya nako-commercialize into an actual usable product by the industry. So maraming source nung problems nun, like funding, yung a company or a manufacturing company that can produce their labs So yun, one example lang yun ng problem kung bakit kulang yung ating transition from lab to commercial applications. Further, are ongoing studies na tinatry nang i-address yung issues na to. So that's it for me. So before I finish my presentation, I would like to thank the following people and institutions lang that made this research possible. So I would like to thank my advisors, Dr. Grace Gregorio from the Institute of Chemistry and Dr. Blanca Villarino from the Department of Food Science and Nutrition. I would also like to thank DOST SEI through the AST HRDP Graduate Scholarship and the DOSTP shared through the Kamote Project for the funding of the research. So thank you very much.
Okay, thank you very much, Rian, for that very interesting talk. I would like to remind everyone, if you have any questions for any of our speakers today, please write them on the chat box. Kindly use this format, your name and affiliation if you would like to identify yourself, the speaker to whom you would like to address your question, then your question. The speakers will try to answer them during the open forum after the second presentation. All right, so our second speaker, Ms. Josette Germaine Abello Kaduldulan, took her master's degree in microbiology at the Institute of Biology, UP Diliman, Quezon City, and her bachelor's degree in biology at the Far Eastern University, Manila, where she graduated as summa cum laude in her batch. She has been in the research field for almost 8 years, but also tried working in a private sales company as a technical sales specialist in her early 20s. Her research interests are in the fields of environmental microbiology and molecular diagnostics. A mother of a 1-year-old super kulit and cute baby boy, let us all welcome Josette Germaine Abello Caduldul. Josette?
Hi po. Hi, good morning po. Naririnig niyo po ako?
Yes.
Okay. So, let's start. So, again, good morning, everyone. So, today I will be presenting about water. Okay, so first, I would like to give an introduction about water. As we all know, that water is one of the most important substances on Earth. So, all plants and animals, and including us humans, need water to survive. So, if there was no water, there will be no life on Earth. So, apart from drinking, apart from its function to be a potable or to be a drinking water, other use can also be discussed. Like it can be used for agricultural purposes and as well as recreational purposes. So it is most important that the water which the people are drinking and using is clean water. So in the United States of America, there is this Environmental Protection Agency or the EPA, which created this Clean Water Act, which aims to protect the public health and welfare and to enhance the quality of their water. So this Clean Water Act establishes a basic structure that regulates the different discharges of the pollutants into the United States, and it also regulates the quality standards for surface water. So yung counterpart nitong Clean Water Act in the Philippines is that uh, administrative order of the Department of Environment and Natural Resources, which classifies yung different surface water natin here in the Philippines. So we have the class A and A, which is used for public water supply. So ito yung mga ginagamit natin for usually drinking or ginagamit for public consumption, and as well as yung class B for recreational water class, and C and D for other agricultural and recreational purposes. However, even though we have this kind of regulation and this uh, administrative orders, still this is causing germs, and toxic chemicals can find their way in our water supplies. So when this happens, water becomes polluted and become contaminated. So there are three types of major contamination that can be found in our water supplies, namely fecal contamination, chemical contamination, and as well as macroscopic pollutants. However, for this morning, we'll only be discussing about fecal contamination. So fecal contamination, it usually conveys pathogenic microorganisms that can cause different waterborne diseases, which poses serious public health concerns, which can result to high mortality and morbidity, and which can eventually result in a major economic losses. So, uh, this fecal contamination that harbors different waterborne diseases is reported to be a global burden, estimated that it costs around 2.2 million deaths per year in the United States of America alone, and it costs an economic cost of around 1 billion US dollars per year, and worldwide, it can cause an economic loss of 12 billion US dollars. So, with this, how can we address this problem of waterborne disease that from contamination? One process is to know or to identify the sources of this fecal contamination. So, good morning, everyone. I would like to share to you the part of our project uh, a study which is entitled as Identification of Agricultural and Human Fecal Contamination through Library Independent Source Tracking. So, microbial source tracking, it is the field that has already been emerged from the late 20th century. So, the aim of this field is to address the different health risks of contamination that is associated with our water supplies. So it is based on the assumption that you have your appropriate methods and you have your source identifier, you will be able to know the source of contaminants or the source of contamination present in our water supplies. So uh, for example, meron tayong contamination which came from unknown sources. And you have this set of methods. You have your biological markers, or you develop a model, and you have your discriminant analysis. You will be able to know the source of the pollution, and which can eventually lead in the eradication of this pollution. So, microbial source tracking has two types of major methods, which is namely the library dependent method and the library independent method. So, yung difference lang nila is that yung library dependent method, you have your host uh, origin database where you have different sources, you have the database of your different target sources, and you have your sample. So what you will do is you do discriminant analysis uh, between your sample and your from your host origin database. You would compare their uh, their patterns, and then you will be able to know yung kung saan galing yung contamination nito from your sample. So usually this method, under dito is yung antibiotic resistance patterns, REP-PCR methods, RLFP methods. On the other hand, yung library independent method, it does not, from the word itself, it does not require a library. It is independent from that host origin database. So the advantage of this library independent method is that it can circumvent any shortcomings of the library based methods since it avoids the sampling bias, and it is less laborious since you don't need to isolate or individually isolate uh, the the origin of the fecal contamination, and you don't need to have to screen large numbers. And another one is that it can allow novel markers that would be difficult or impossible to get by culturing. Okay, so this library independent method is divided into three types of methods or processes, namely chemical methods, molecular methods, and viral methods. But for today we will only be discussing, we will be only be focusing on molecular method. So for chemical method, just give brief background. So ang sinasabi dito is that you are using different types of chemical compounds such as caffeine, cerols, and bile acids to detect the human contamination present in the environment. So I don't have any background with regards to this, but it is published that there are these studies na ginagamit ito for the identification of such contaminations. And then for the molecular method, you use your host-specific primers, or you use a host-specific PCR analysis, which is you would assay directly the sample and you would extract the DNA from it and then subject it into PCR to identify yung specific contamination. So usually the molecular methods ginagamit dito is the markers like human mitochondrial DNA, uh, E.coli toxin genes, and bacteroidelis gene markers. And lastly, yung viral, which uses host-specific fecal viruses such as adenovirus and enteroviruses that detects the presence of these viruses detects a certain human contamination or agricultural contamination in the sites. However, one of the limits of this viral method is that you need to requirement of a larger water sample greater than 100 ml is needed para ma-analyze or ma-isolate mo yung mga virus na ito. So, ayun. So, again, for today, we'll only be discussing molecular method. So, one of the uh, common or one of the uh, common genes that is associated with molecular methods of library-independent microbial source tracking is the E. coli toxin gene. So, as we all know, that these toxin genes are used to characterize the different types of E. coli according to their pathogenicity. However, these toxin genes are also reported to be used in source tracking. So, as per the study of Katif et al., these toxin genes of enterotoxigenic E. coli markers were used to identify the presence of cattle and swine feces in a certain water environment. So these are the two toxin genes that has been used, the heat labile toxin 2A and the heat stable toxin 2 by from cow, the LT2A from cow, and the SE2 gene from swine. So, what is the advantage of using this toxin gene? It is reported that these two genes have great host specificity, and it's presumed to be have a geographically stable. Another reported gene marker is the human mitochondrial DNA. So it was proposed as a marker based on the premise that it would be abundant in the feces. And it was shown that it has 100% sensitivity and specificity using a Tacman qPCR. And the most common human mitochondrial target gene is the human mitochondrial NADH dehydrogenase subunits. So now, in the Philippines, there's still no published article regarding in the field of microbial source tracking. Only that there is a study regarding the bacterial indicator in association with diarrheal disease and the presence of this fecal contamination in the different water resources. And one of the greatest problem nowadays of DNR is that they are in need of regulation and proper rehabilitation of the different bodies of water here in the Philippines, especially in especially in the biggest water sources, which is the Laguna Lake. So, as we all know, Laguna Lake is the largest inland body of water in the Philippines, and it is the third largest freshwater in the Southeast Asia, and it is classified by the DNR as a Class C water body. It has 9 lake stations and 21 major tributaries. However, all of these major tributaries and these lake stations exceeds the total limit of the DENR of 5,000 mpn per 100 ml. So basically, meron talagang contamination or fecal contamination present in the tributaries and in Laguna Lake. So we have this kind of problem. So we have these various contaminants present in our water system, especially in our Laguna Lake, and it can be from unknown sources. And with this, we only have the limited proper treatment for this water system. And given that we only have this limited proper treatment, it can result in the greater contamination of different water sources in our country. So with that, the objective of the study is to identify the different sources of fecal contamination in the water system, such as in the selected stations and tributaries of Laguna Lake. So for the research proper, uh, since this study is a part of a bigger project, I would only discuss about the four major sites that I have personally worked on to. So those sites are the Laguna Lake Station 1, Laguna Lake Station 5, Mangangate River, and the Alabang River. So the methodology of this study was divided into two: MST using cattle and MST in cattle and swine sources, and MST in human sources. So to further discuss about this, MST using E.coli toxin gene. So the study was able to collect water from the different sampling sites during the months of May, July, September, and November. So the collection of water sample is 500 ml and in duplicate for each site. And then this was subjected into tenfold serial dilution and subjected it into membrane filtration technique using membrane tolerant E. coli MTech agar, and then it was subcultured into eosine methylene blue agar for the confirmation of E. coli. Further identification and confirmation of the identity of E. coli was done using molecular confirmation gamete UIDA gene. And then all confirmed E. coli was undergone PCR analysis using LP2A and SC2 genes to characterize if those E. coli uh, came from uh, swine or cattle contamination. So the another leg of the study was to identify the human fecal contamination. So again, a collection of water sample was done in duplicates, and then from here, direct DNA extraction of the water sample was done, and then it was subjected into qPCR analysis using human mitochondrial gene to know the DNA copies presence of the gene and data processing and analysis. So I would just like to share to you the primers that has been used in the study. And for the data analysis, for the dependence of the LP2A and SC2 genes between the sampling site and sampling period, a chi-square test of independence was done. Now, for the research findings, I've divided the discussion into two. So the E. coli toxin gene as a biomarker for agricultural contamination and the human mtDNA for human fecal contamination. So first, let's go to E. coli toxin gene as a biomarker for agricultural contamination. So all in all, the study have isolated 424 E. coli isolates divided into the following numbers. Where in Laguna Lake Station 1, we have 81, Laguna Lake Station 5, we have 62, and the most number came from Mangangate River. So it is not, hindi siya nakaka-surprise since in LLDA, most number of fecal coliforms were really found in Mangangate River. And in Alabang River, we have 90 E. coli isolates. So these confirmed isolates were subjected to LP2A and SC2 gene, and this is the result. So we have seen that there is an abundance of LP2A gene present in the sampling site. So what is the implication of this? The amplification of LP2A and SC2 gene represents the association of E. coli in the samples, E. coli samples with cattle and swine, mostly in cattle contamination. So it is quite questionable since makikita nyo in this figure, most of the sites are near residential and commercial or industrial sites. However, how come there is a presence of cattle or swine fecal contamination in these following sites? So the presence of E. coli toxin genes among these sites can be cause of the different agricultural and industrial effluents present in the following surrounding sites, such as small-scale livestock backyard farms, cattle and swine abattoirs, and meat manufacturing companies that are usually found on those sites. And other than that, the effect of physicochemical parameters such as BOD and BO as well as monsoon season can affect the presence of this fecal contamination. Nevertheless, the presence of this contamination indicates the presence of these toxin genes indicates that there is a fecal contamination from cattle and swine, and it must be addressed. So next is we can see that the presence of E. coli toxin genes among these sites is uh, uh, can be seen as it has a dependence between the sampling months and the presence of LP2A gene using the chi-square test of independence, and the presence of LP2A gene declines during the month of September, and for the Mangangate River, it declines during the September and November. So what could be the reason? This could be due to the physical chemical properties or during the monsoon season, where during this time it is habagad in our country. So it is the presence of southwest monsoon, which is characterized by a frequent heavy rainfall and humid weather. And because of this, it can result into frequent runoff of water, which can eventually result in the decline of E. coli during this month. Okay, so for the summary of findings, E. coli toxin genes, the PCR-based assay demonstrated the use of these two toxin genes of E. coli as a biomarker for cattle and swine pollution. And there is a prevalent presence of this LP2A gene, which indicates cattle fecal contamination among the sampling sites. And there is a relationship between the presence of LP2A gene among the sites and among the theories. Now we are done with the E. coli toxin genes. Now let's go through the biomarker for human fecal contamination. So for the human mitochondrial or DNA or the mtDNA, we have collected a total of 15 genomic DNA samples. So the DNA quality were said to be passed. Chinek po namin sila using a available fluorometer and available kit for it, and all of their quality is okay. And then from these gDNA samples, all of them were subjected into qPCR analysis, and then followed by standard curve analysis using qPCR ulit, and then to identify the different DNA copy numbers. So here we can say that there are a lot of DNA copy numbers found in Laguna Lake Station 1 and Alabang River. So the number 1, 2, 3, 4, it only indicates the sampling periods. 1 for May, 2 for July, 3 for September, and 4 for November. So with the given amount, we can say that most of the DNA copy number of this human mitochondrial DNA was found in Alabang River and as well as in Laguna Lake Station 1. So how come there are a lot of human mitochondrial DNA found in these sites? Basically, Laguna Lake Station 1 and Alabang River has been surrounded by different residential sites and as well as industrial sites. So the result can be associated because of the presence of this uh, following establishments. So as we can see dun sa previous figure, no, we can see na it is really surrounded by different commercial and residential sites. How about in Mangati River? Even though we can say na parang mababa yung count niya as compared dun sa dalawang sites. So the presence of or the low count of this human mitochondrial DNA in the Mangangati River can be due to the different abiotic factors such as water temperature, pH, flow rate, turbidity, and as well as other biotic factors such as in and presence of enzymes and the presence of microorganisms. Since sobrang this Mangangati River is as in sobrang contaminated talaga siya if you would see it in person. So, in addition to that result, we also you can also see that the different sampling periods show no connection in the prevalence of this human fecal contamination in the different sites. However, hindi natin siya pwedeng ipawalang bahala since the mere presence of this human mitochondrial DNA indicates that there is a fecal contamination and there is an intense land use in that area that affects the health of this water body. So this can be alarming since the lake water system is used for irrigation and cultivation of the different small backyard farms of vegetables and fishes in the area as well as sa mga katabi pa niyang area like in papuntang Rizal or papuntang downwards, papuntang Laguna. So mtDNA is a geographically stable marker. So it is two of the most utilized human mtDNA is cytochrome B and NADH gene. However, the most popular is the use of NADH gene. So mtDNA could persist longer in the environment as compared to other MSC markers, and it has been reported that there is no cross reaction between the effluents from the human target to the non-human species of interest. So as you can see in the figure, using the Mel curve analysis, you only see single peak between the samples and the positive control. Yeah, by the way, we've used human fecal sample as a positive control, and for the cattle and swine analysis, we use cattle and swine fecal sample. So the indication of the single peak in the Mel curve indicates that the behavior of the samples and the positive control are the same. So basically, isa lang sila. So it is very, very specific. Even though the samples are gDNA and it came from direct extraction from water sample, and as well as sequencing result from the use of human mitochondrial DNA in human fecal DNA show that it is a Homo sapiens mitochondrial mark. So for the summary of findings, we can discuss that qPCR-based assay was done to detect for the human fecal contamination in the given water system. The study was able to detect human mtDNA among the sampling sites and in human fecal DNA, and the most number of human mtDNA was found in Laguna Lake Station 1 and in Alabang River. So for the conclusion and recommendation, microbial source tracking was a useful method in determining the possible causes of microbial contamination in the different water system. And the study was able to use a library-independent platforms, one focusing on the microbial species as biomarker, and the other one is the mitochondrial biomarker. These markers are reported to be host-specific and does not require large amount of water samples for detection. Hence, it is less laborious and tedious. And the finding of the studies can be used as the basis for drafting regulations and managing the land use of the area surrounding the lake. So for the recommendation, investigation on the different sewage water treatment facilities as well as other tributaries and stations of the lake can also be done. And the use of other biomarkers as to compare kung ano ba yung best fit in our best marker to be fit in our system can be done, such as the use of bacteroidales gene marker as well as varial markers. And a year-round sampling can also be done for monitoring purposes. So these are just my references, and I would like to thank the following institution: the Laguna Lake Development Authority, the DOSCP shared for the funding, the Institute of Biology, and a previous lab, which is the Pathogen Host Environment Interaction Research Laboratory, the BRSL laboratory for this opportunity. I would also like to thank my thesis advisor, Dr. William L. Rivera, and my project leader, Ms. Joy Ann P. Santos, for their guidance. And I would also like to thank Ms. Pierre Angeli Vital for this opportunity. Thank you very much, and to God be the glory. So that's it. Thank you.
Thank you very much, Josette, for another informative presentation. So again, if anyone has any questions for our speakers, continue to send them using the chat box. So just put your name, your affiliation, if you would like to be identified, and then the person you would like to ask, as well as the question. And then stay on until the end of the Q&A for the link to the evaluation form. So let's begin the open forum. I will now read questions from the audience. So the first question is for Mr. Rian Sarsa. Is there a PAD BAM?
Based po doon sa nabasa ko, for now, since ang PADS is mostly nasa lab setting pa, hindi pa siya nako-commercialize, wala pang any official method or any policy na gumagamit ng PAD as an analysis method. So parang ang status niya right now is more of preliminary testing than actually being an official method of analysis.
Okay, thank you. So I guess that leads us to the second question. So are PADs recommended to include on PNSDW and EMB-DENR for drinking water and wastewater?
For that po, so almost the same answer from the previous question. Since hindi pa kasi siya commercialized talaga, hindi pa siya na-include sa mga official methods of analysis. And mostly nagiging parang preliminary determination lang siya. So kunwari, we have a water sample, determine lang nila, let's say, heavy metal content using the pad. Pero kailangan pa rin nila gumamit ng official method na instrumental para i-release officially yung results na yun. Parang confirmatory mo right now is yung instrumental, more of the initial preliminary yung ating pads. So hindi pa siya kayang mag-stand alone as a method of analysis. Pero in the future, baka pwede naman po siyang gawing standard method. If resources allow it.
Okay, thank you. I guess I'll ask the same question to Josette. Would you recommend the LIM to include in the PNSDW and EMB-DENR for drinking water and wastewater?
For the identification po, ma'am, I think it can be kasi it can address actually yung long problem natin with regards on the presence of fecal contamination. Kasi as of the moment, the process is for only identification of the fecal contamination in the site. So if we could address or if we could suggest to address the sources of contamination in those water, it would be better, I think, para mas magkaroon tayo ng parang maigting na regulation in terms of the quality ng drinking water and as well as dun sa pagpaprocess ng wastewater natin. So, yun po.
Okay, thank you. So I'll ask you the question that just arrived. So what do you think the LGU can do to address the agricultural runoff in Laguna Lake? Suggestions? Would you know what they're doing right now?
Yeah, actually po, this project kasi, this study is part of the bigger project. So, what we did na nung nakaraan is that we had a meeting with all the programs po and as well as yung other projects with Laguna Lake, and meeting po yung different stakeholders as well as yung different representatives of LGU officials, and we presented the data with them. So, pinakita namin na this is happening and this is the possible thing na pwede nating i-address or pwede nating gawin with regards on persistent contamination in the lake po. So, ayun. Yun po.
Okay, so thank you. So our next question is, does your research involve eDNA of bacteria such as E. coli? eDNA.
No, hindi po. Hindi po ako nag-target ng E. coli. eDNA na. eDNA as in environmental DNA po or mtDNA?
I guess E daw eh.
Environmental DNA of bacteria, hindi po ako nag-use ng markers for specific, what do you call this? Parang for bacteria. But yung toxin genes po is an E. coli derived biomarkers. And from that biomarker, actually, yung huling paper na nabasa ko is that toxin genes can be directly applied in environmental DNA. So, like if you have your environmental DNA samples, then you use this toxin toxin biomarkers, you can actually identify the source of contamination. So, kaso yun nga yung naging limit ko that time. I've used the E. coli kasi to confirm then it's from E. coli. So, ayun lang. Since hindi pa siya sobrang studied here in our country.
Thank you, Giselle. So the next question, also for you. Does DNA copy number have a threshold to say that it came from feces?
Yung CT, with regards po, if this is a CT value, hindi ko po siya, as in yung alone samples, hindi ko po siya na-check. However, with regards to positive control, using human fecal DNA, nagkaroon naman po siya ng same behavior. If you could kita po yung melt curve analysis ko, same behavior po yung positive control and as well as yung sample DNA. So, basically shows po na it came from human fecal DNA. So, it also confirmed nung naran yung melt curve na yung markers is used for human fecal contamination. Kasi since the sample came from human fecal sample. So, yun po.
Okay, so this is the last question, also for you, from Shelo Parawan Villarreal from Bulacan State University. Why choose Laguna Lake as your sampling site, and are the people exposed to this water?
Hi, Shelo.
Regards daw to Zion.
Hi, Shelo. How are you? Thank you for that question. Actually, I chose Laguna Lake sampling site. Well, aside from it is a part of a bigger project, it has also been used as a water source for different irrigation ng mga small backyard farms along the area. And it is since it's the largest inland body here in the Philippines, marami siyang pwedeng gamitin. And yes, there are people exposed into this water, especially dun sa mga selected sites ko, especially in Mangangate River. Yung mga nakatira kasi talaga doon, as in immediately katabi nila yung river. And it is not, syempre, hindi siya good with the health given na maraming contaminants present in that. So, yun. Thank you.
Okay, let me check. There are other questions. So ito. I'm not familiar with mtDNA that much, but do mtDNA from feces have a different melt curve from mtDNA skin?
Ma'am. Thank you for that great question. Actually, I have yet to know. So, I can, yeah, kasi hindi po ako nag-sample ng mtDNA from skin. So, uh, pwede naman siyang i-check and then extract po yung DNA and we can check if it's the same behavior with that of the fecal DNA. So, ayun, pwede ko po kayong balikan dyan.
Okay. So thank you. I think that's all. Wala nang ibang questions. So thank you for sending in your questions. And then thank you also, of course, to our speakers, Mr. Rian Martin Sarsa and Ms. Josette Germain Abelio Caduldulan. So I will now present you with the certificates of appreciation. Asan na? Okay, so this certificate of appreciation is given to Rian Martin Sarsa, MSc, teka may nakaharang, for having delivered a lecture on paper as a detection tool during the BRSL webinar series number 5, The Power of Detection from Microbes to Chemical Compounds, held on February 16, 2021 via Zoom, signed by the BRSL head, Dr. Pierre Angeli Vital, and the NSRI director, Dr. Elmer S. Estacio.
Thank you po.
Yeah, thank you, Rian. And then also for Josette, this certificate of appreciation is given to Josette Germain Abelio Caduldulan, MSc, for having delivered a lecture on identification of agricultural and human fecal contamination through library-independent source tracking in selected stations and tributaries of Laguna Lake during the BRSL webinar series, Episode 5, The Power of Detection from Microbes to Chemical Compounds, held on February 16, 2021 via Zoom, signed by Dr. Pierre Angeli Vital, BRSL Head, and Dr. Elmer S. Estacio, NSRI Director. Thank you also, Rian. Now, to formally close this webinar, I now turn you over to the head of the BRSL, Dr. Pierre Angeli Vital, for the closing remarks.
Thanks, Erna. Good morning, everyone. Can you hear me? I am sure that all of you are having a great morning, so please allow me to thank the following. First, of course, our dynamic young speakers, Mr. Rian Martin Sarsa and Ms. Josette Germain Abelio Caduldulan. I am just used to calling her Joseph Abelio. Both of them are hardworking researchers from our lab, BRSL. And as I would always say, mas expert sila mga researchers kesa sa akin. And what better way to start the year than to feature our very own. I find it amazing that they are able to juggle between their work with a lot of deadlines, studies, successfully finishing graduate studies recently for that matter, and even their personal lives. So, with their talks and stories, I hope the youth in the webinar and even other generations where I now probably belong to follow the same science track or path as Rian and Joseph. Second, this webinar will not be possible without the support of our new NSRI Director, Dr. Elmer Estacio. Salamat, Sir Tux. And the efforts of the remarkable researchers and staff of BRSL. And for this webinar, they are wearing blue team as a theme. So guys, if you're capable of turning on your videos, please do so to be recognized. If it is not too much to ask, I would like to ask our participants to please click the clap or heart button to show our appreciation to the organizers. The credit, of course, goes to them. Thank you po. So our MC already shared with you the available resources and services at our Lab Biological Research and Services Laboratory in Natural Sciences Research Institute, University of the Philippines, Diliman offer. Although our lab is still physically closed, we are accepting online consultations and continue to organize webinars such as these. So please feel free to email or contact us if you have biological concerns. Also, stay tuned with our BRSL Facebook page for updates. Third and last, I would like to thank all of you, our dear participants coming from all parts of the country and the world, the universe rather, who show great interest and enthusiasm in biology and its allied fields and joined us this morning for the BRSL webinar episode 5, The Power of Detection from Microbes to Chemical Compounds. And with this, I wish you to have a wonderful and safe day and week ahead and hope to see all of you again in our